Good afternoon. Can you hear me? Can you hear me in the back? All right, great. Good afternoon and welcome. I'm really pleased to see you here today. I'm Scheirman. I'm Dean of the Jackson School of Geosciences, and I'm very pleased to be here to introduce our speakers for this Fireside chat, and in particular to welcome our special guest, Yuri Sebregts, who is the Executive Vice President for Technology and Chief Technology Officer for Shell. As such, Yuri plays an exceptional role, an important role in setting the company's strategic directions. And of course, as one of UT's very important research and recruiting partners, Shell's decisions today and the directions that they are going in the future bear weight on what we are doing at UT in terms of research, in workforce development, as well as curriculum. We're trying to prepare our students so that they will be successful not just now when they get out, but also 10, 15 years in the future. Today we're going to hear from Yuri about how he will spend $1 billion to help ensure, or would spend $10 billion to ensure a sustainable global energy future. That's an amazing question. How many people have had the opportunity to think about what they would do if they had $1 billion to spend? It's a great question. I'm dying to know the answer. As leader of the global company, our distinguished guest today asks himself that sort of question daily. The format today is going to be a question and answer session, fireside chat, and it'll be moderated by two of our distinguished UT students. And I'd like to introduce the students to you now. The first one is Joan Scheirman. Joan is a first-year MBA student concentrating in energy finance and strategy. She's co-president of the Energy Finance Group, an organization that serves as a resource for MBA students pursuing a career in the energy industry. She is a Houston native and graduated from Vanderbilt University with a degree in mechanical engineering. She began her career by working for ExxonMobil's project management division, where she primarily worked on marine well containment system aimed at responding to subsea well control incidents. She then transitioned to a career in oil and gas consulting, where she focused on upstream and downstream growth and operational strategy. She plans to transition back into the energy industry upon graduation from McCombs and will spend the summer working for Apache Corporation in strategic planning. Our second student is Karan Jerath. Karan is a senior petroleum engineering student. He's the youngest member of the 2016 Forbes 30 Under 30 energy list. He's also United Nations Young Leader for Sustainable Development Goals. The 17 young leaders were selected from more than 18,000 nominations and work with the Office of the UN Secretary General's Envoy on Youth on efforts to engage young people in the realization of the goals. His patented invention targets remediation methods for subsea oil spills and has earned him an Intel Foundation's Young Scientist of the Year award. Through these platforms, he advocates for youth involvement in STEM education along with ocean preservation and conservation. Inspired by the gift of a planet, which I would love to see, by a gift of a planet he received from MIT's Lincoln Laboratory, Karan has launched Planet North 25 as a youth social impact effort to develop data-driven solutions to systematic changes within targeted regions of the world. He called this planet True North Star and is focused on accelerating youth entrepreneurship, STEM education, and energy sustainability. Upon graduation this spring, Karan has accepted a position with Deloitte in Austin. Please help me welcome our student moderators. And now it's my pleasure to introduce Yuri Sebregts. Yuri, as I said before, is the Executive Vice President Technology and Chief Technology Officer for Shell. He leads a global technology organization which combines technical, scientific, and commercial expertise and is responsible for Shell's technology strategy and new technology development, as well as internal technology commercialization activities. These range from research and development programs delivered in-house and through collaborations with external partners, including the University of Texas, to deploy technologies across Shell's operations, as well as a catalyst for manufacturing and sales, technology licensing, and technical services to third parties. He also oversees the company's digitalization activities to apply proven and new digital technology to Shell's existing businesses and emerging new business models. He completed his MSc in chemistry from Leiden University in Netherlands and joined Shell as a technologist in 1991. Yuri lives in the Netherlands with his wife and his two twin 18-year-old daughters, and he and his daughters are preparing themselves so that they can climb to the top of Kilimanjaro this summer. It's his first time in Austin, I hear, and we would like to welcome you both to Austin and to the University of Texas at Austin. Please welcome Yuri. And before they start, I just want to let you know that Karan and Joan will be asking questions of Yuri, but we have left time at the end for question and answers. And there are mics here, and please, particularly students, don't be shy about coming and being prepared to ask questions yourself. So with that, I'll give you our fireside chat without the fireplace.
Well, thanks everyone for being here, and particularly to Yuri for joining us. Since it's your first time in Austin, we had talked before we jump in about hearing kind of how you've enjoyed the city so far and your favorite thing about campus. So.
Oh wow! Yeah, so I've been here all of all of 5 hours, so I've got a deep, well thought through. All the people that I met, I was struck by the broad perspective they have on the energy system, not looking at it from their one single dimension, but thinking about all the complex issues that you have in there, as well as bring their own particular area of depth. And then touristically, I think it's a beautiful campus. I met your president this morning, and he's in the most amazing office that I've ever seen, and I've been in lots of offices of senior people, and I've never seen something like this. So that was quite impressive as well.
Great. All right, we'll get started here. So when we think about kind of the future of the energy industry 20 to 30 years out, we're looking at a mix of traditional energy, but also the undeniable growth of renewables. How are you and Shell thinking about the energy transition and particularly sustainability, and kind of what does that mean for you and for the company?
Okay, so Shell embraces that not only is energy critical to quality of life for people in the world, but that at the same time we also need to transition to another system, a next wave and a better system, because we think climate change is man-made. We have no kind of doubts about that at all. And we also realize that the way energy is currently created and supplied to people leads to air quality issues in the world's major cities. And so we need a system that continues to provide people access to reliable and affordable energy so that they can continue to either have the quality of life that they already have in developed worlds, or get to a better of quality of life than they currently have in less developed parts of the world. And we need a system that prevents catastrophic climate change and gives us better air quality. And that's tough to do. When we think about the path that gets the world there and what role we might play, we think this is first and foremost about demand transition. It's not so much about producing less of the energy sources that we have today. It's moving demand to another type of energy consumption, increasingly electrified, but there's other ways you can think about it as well. And then kind of supply follows. Now, demand transition then is not one thing. It has a number of elements to it. The first and easiest to kind of fund, because it's self-funding, is that if people improve their efficiency of use, yeah, if they use less energy to achieve the same outcome. According to our models, if we look at trends, a person anywhere in the world needs roughly 100 megajoules a year to live a decent quality of life. Many developing nations are at 50 or less. Some countries in Africa are at 10. But a typical person in North America is at 350. So we should be able to have the same quality of life at 100. That means per person 3.5 times less energy. Yeah? And it pays itself back. So that's step one that we need to pursue. Then the next step, still easy, is the electricity that we increasingly need. We should not make from coal. We should move from coal to ideally renewable electricity, wind or solar. And at times and at places where there's not enough wind and sun, then we can have gas as a backup, but ideally not coal. And then different people have different opinions about nuclear, but we don't do nuclear, so I don't have a particular opinion about that. Then the next easy thing is to electrify where we already have the technology, say light duty mobility. Smaller cars and vehicles, we have the technology to electrify. And that will certainly help. Bit more difficult is heavy duty. How do we transition the demand for heavy duty? As of today, there's no batteries that's good enough to drive a really heavy truck over, a full day of driving anywhere. So that's going to be harder, and maybe we need hydrogen fuel cells or something like that. Even harder to transition demand after that is industry. World needs, steel, cement, fertilizers, all kinds of industrial processes that use vast quantities of energy. We have no technology today to electrify, so this will take a lot longer. So maybe for those we need carbon capture and sequestration, And then finally, the most difficult, aviation, flying, a big jet with 350 people halfway across the world. We're not quite sure whether we can ever electrify that. So we probably need biofuels or things like that. And so all of that needs to happen, and all of the above needs to happen, and all of it needs to happen fast in order to stay within 2 degrees sea temperature rise. So that demand transition we really need to pursue as fast as we can, and that's where we hope to make a contribution.
Are you able to put a timeline on when you see these particular targets being achieved?
So we try not to make predictions. As a company, we've stopped making predictions in the early 70s. Until that time, we, for instance, tried to predict the price of oil, because it's kind of relevant to our business to know what the price of our main product was going to be. By now, by the way, oil is no longer our main product. Most people think it is, but we produce a lot more gas than oil, but that's aside. But then in the early 70s, we kind of came to the insight that this is too difficult. So we switched from predicting the future to scenarios. So what we've been doing since the early 70s is look at what are credible futures, techno-economically and politically, where might the world go? What are kind of the credible end members of, the various degrees of freedom that the world has, and how would our business, fare in one scenario or in another? So we currently have 3 scenarios in our company. They all have names, and I won't bore you with all the content. One is called mountains, another is called oceans, and the third one is sky. And sky is a so-called normative scenario. That's where we look at what an outcome is that we would desire for the world, and then work back from that what would have to be true today in terms of technology, economics, political realities, etc. And the sky scenario is one where the world would continue to develop and people would have access to the energy that they need, the 100 megajoules a year, and temperature rise globally would be less than 2 degrees C. What would have to be true? Now, we can see a world techno-economically where we achieve kind of net carbon neutrality around 2070 with a pathway that would keep the climate below 2 degrees temperature rise. It's a very challenging scenario. Lots of things have to go right. We need lots of cooperation within societies and between societies. And we need good policy, and we need technology breakthrough, and a number of other things. But it's technically possible to do that. And so net carbon neutral i.e. emitting as much as you would capture and reuse or store, could happen in our scenarios around 2070.
So in light of kind of the energy transition and needing to balance traditional energy sources with the growth of renewables, how is Shell approaching this from an R&D perspective? You know, where do you see investments now? How do you see that shifting over the next few decades?
Yeah. So the balance of our R&D portfolio is typically 10 to 20 years ahead of what the balance of the business is. Yeah? So the question, how do you spend $1 billion a year on R&D? Of course, I don't know exactly what the right answer might be, but I listen to lots of people. But there has to be some balance between technological innovation that keeps our existing businesses competitive and technological innovation for the longer term and for new businesses. And that mix should, be roughly, 20 years, a couple of decades ahead of today's business. So if in today's business we invest as a company about $25 billion a year in new assets and new products for customers, and over the next 2 years up to $2 billion a year of that would be in new energies, so the sustainable electricity type business that we grow, then in R&D it should be substantially more, and it is substantially more. Now we don't advertise exactly how much. And the reason is that whatever number we throw out, we get criticized. So that becomes a fairly pointless, kind of dialogue. But it is a lot more on things like offshore wind and solar energy development and next generation batteries and all those things than we would, invest in our business today. Because I cannot predict the future and exactly, which energy end use will be the major one in any particular, use case, such as mobility or, home heating and cooling or whatever. We place lots of small bets on those energies that look decades out, and we make sure we stay at the forefront of all of them, ideally in partnerships with others, and then we see which ones become, naturally the front runners.
On the topic of energy companies starting to transition into cleaner and renewable energy, what do you feel allows Shell to keep that a competitive edge? And why do you believe that companies like Shell should be the ones that are continuing this trend?
Well, we have to leverage the innate strengths that we have. At the same time, we shouldn't shy away from making fairly bold moves. And if you put your mind to making a fairly bold move, it's quite possible. If you look even at the history of our own company, it's not your company, hopefully you'll join me at some point in time, or even, might get there after my retirement. The company started 130 years ago, roughly, by pivoting from trading seashells to bulk transport of oil. Now that's a fairly gutsy change in business model. And that's the start of the company. At least the company as an energy company. It existed, trading seashells before that, hence the pectin. It then successfully developed that business. It came to Texas, Spindletop and all that kind of stuff. And then in the 1920s, a large part of the world nationalized many of the upstream resources, in Russia and in other places. And the company quickly had to reinvent itself as a marketing company. So it built what is now the most powerful energy brand, the most trusted, the most recognized energy brand in the world. So it shifted from a pure upstream play to a lot of downstream marketing. So that's a transition that's possible. Later on in the kind of Second World War in the 50s, it was part of reinventing the chemicals industry, going from coal tar and acetylene to, oil and gas and ethylene-based chemistry. In the 70s and 80s, the whole industry had to clean up its act around refining with, the whole different, way of taking the sulfur out and the NOx. Then here in this part of the world in the 90s, it transitioned from onshore to deep water. A very fundamental shift in, the skills and the technologies that you needed. And the last 10 years we had shale revolution and resetting the entire industry successfully from $110 oil price and the derivative gas price to kind of 39 and back up to about 65. So transitions are part of history. It's normal. What can we do? What's our strength? as a large international energy company. We're really good at technology commercialization, bringing a whole ecosystem together that takes technology when it's ready to come out of the lab and do the commercial innovation that goes with it and deploy it at scale. With the energy transition, that's a usable skill and a usable capability. We're really good at doing very large project management, projects at the largest scale that you can think about. That's an important skill. And the energy transition, again, is a large societal change, and that skill will be helpful. And the third thing that I just touched upon, we invented a very, very well-known, well-respected and trusted brand in the 20s that's, almost a century later, worth twice as much as any other energy brand in the world. 45,000 retail outlets around the world, that's more than McDonald's or Starbucks, are all places where you can offer people access to new forms of energy, where they might stop by, they trust you that you're good for the product that you promise, and if there's something wrong, you'll come and fix it because you've got the financial strength and the capability to do that, and that helps you build a new business. So I'm quite confident that as a company we can do that.
I want to jump back to something you talked about a little bit earlier in terms of developing countries and how access to energy has improved quality of life in these countries and the demand is still growing. How do we balance, particularly in the short term, continuing to give these countries access to energy while also lowering carbon emissions?
Yeah, of course, I don't have a crystal ball on a question that's that large and that complex. As a company, we believe that kind of balancing isn't quite going to get us there because different, societies, different communities will have demands that need to be met. So developing countries and those societies are not going to be willing to trade off the speed at which they acquire a better life so that somebody else somewhere else in the world can, keep having the life that they have and global climate change is averted. Those societies will want the same access to energy. And we need to segue the energy system to something else. So it's not a trade-off. We need to come up with solutions that get both more energy and cleaner energy, brought about. I mentioned some of the scenarios. Some's about 100 megajoules per person, you need every year. How do we collectively globally get there? Well, again, in North America and in Northwest Europe, we really need to start to being a lot more careful with how we use energy. And just, rather than use 350, use 100 a year and have the same quality of life. That will be part of the answer. In emerging societies, in developing societies in Africa and India, we need to provide access to energy, and we should probably, if we can, jump some of the legacy technologies and go straight to mini grids based on solar and wind, etc. However, those countries will need backup systems for their electricity as well. Can we help them develop access to gas rather than use local coal that's cheap and available, but not very good for the climate? So it has to be both. You have to come up with solutions that allow you to do both. As a company, we have set ourselves a goal to provide 100 million people in the world access to reliable and affordable electricity that don't have it today. So there's still almost 1 billion people in the world, predominantly in Africa and in India and in some parts of Southeast Asia, that don't have access to electricity. And try and imagine what life is like without electricity, in terms of access to just safe food. You can't store your food against, heat making it go bad. Being able to read and study at night and, develop yourselves and your children to study and so many other things that you get out of that. Now, we can't solve it for the whole billion, so more people will have to chip in. But we're committed to help by providing access for 100 million people. We do that in some parts directly, in other cases by investing in other local companies that help us deliver that. So we've co-developed and invested in a company called Solar Now that has 50 branches in Africa to provide access to local solar and then electrical appliances. And another company called Husk Power that does the same in India and has 50 mini-grids up and running now. And we expect to build that as part of a total global business in renewable electricity, also in the developed parts of the world, which is going to be, a new vertical pillar, a major business that exists next to the businesses that we're already in Shell, which is gas, which is growing, oil, which is kind of stable to declining, chemicals and lubricants.
One main topic that you've been hitting on is working with the public sector, whether it be working with developing nations that are building infrastructure or in developed nations that are now actively trying to work on the Paris Agreement. How does Shell balance these dynamic political environments, especially the ones we've seen in today's environment?
Yeah, political environments are complex. They always have been, but they go through periods where they're slightly less complex and periods when they're more complex. And in quite a lot of countries around the world right now, we've got societies that are more polarized than they were a couple of decades ago, and what's the right path forward. Because as an energy industry, we've always had to do business in countries that have complex politics. We've got a concept that we call country risk, or non-technical risk, that you just have to deal with. We could wish it away, but it doesn't go away. So how do we, hedge our bets and work in a way where our total business doesn't collapse if suddenly a certain country wants something that we can't do. What we learned over the 130 years of existence is that you have to commit yourself to plans and goals that stand the test of time, that are not driven by today's political reality in country X, but where you say, what would make sense in the long run? And that you're really transparent to all your stakeholders, be it politics or civil society or customers or investors, really transparent on what you are there to do and how you go about it. So one of our board members calls it play the long game and play it straight. And I think dealing with political complexities continues to be something that we have to do, and we have to do it in that way. Have a longer term promise to societies that stands the test of time, and do what you promise, and don't promise what you know you can't do. And I think we'll get there in that way.
Going to shift our focus more towards the technology side now. So technology has really revolutionized the energy industry, both if we think about the shale revolution and our ability to generate renewable energy more efficiently. What kind of key innovations do you see being necessary going forward to kind of improve sustainability and make sure that we can kind of meet this energy transition in the future?
Yeah. So the role of a CTO is not to try and be some sort of sage that says, that one technology out of 1,500 is going to be the right one. Yeah. It's about shepherding an ecosystem that you've inherited from your predecessors and make sure it has the capabilities to capture opportunities as they come about, and has the capability to try different things and learn from what works and what doesn't work, and then build on that. I have inherited from my predecessors a technology capability that is absolutely leading in two core areas that are differentiating and key to our business. One is managing risk in the subsurface. We are in a business where we have to develop resources that we cannot see and touch, and we have to make an assessment around something that we cannot see and touch based on part information, and then have models and ways of interpreting data that make the right decisions. And that's a set of capability around geology and geophysics and petrophysics and a number of other areas, and then how you deploy that to make decisions, risk-based decisions. So that's one core technology area that we nurture, and we make sure that we don't lose that, and it will continue to be very important. The second one is turning molecules into other molecules. In order to use that resource base and make products that people want and need, we have to work on the molecules, and there's many varieties of that. There's, treating the oil in refineries into, products that meet the specifications that society expects in terms of cleanliness, air quality, performance, what have you. It's using part of those molecules and make them, chemical building blocks. It's treating gases that, you can't use as co-products and you want to do something else with. It's formulating lubricants, making the components that make them up. So that's a combination of process engineering and process development and catalysis. And that's the second area that we nurture, and it's very important for us, and it will continue to be important for us. At this point in time, I think, my team and I are adding 2 areas in terms of growth and, capability, because it will be key for the future. The first one of those 2 is more important in the long run, and that's adding electrochemistry back into the mix. The world kind of forgot about electrochemistry largely, shortly before the Second World War, and it was all, thermochemistry and catalysis. But with an electrifying energy system, electrochemistry is back. The good news for us is there's not really anybody that's a front runner that's way ahead of us, because everybody's really discovering this, including leading universities are building back up their depth in electrochemistry and bringing that back as a major topic. So that's an area for us to build, because it's going to be really important. The other one is computational science. We've used compute power for a long time to deal with data, but the last decade or so, the ability to use compute power to solve problems in a different way has exponentially come about. And that's both physics-based modeling at a whole level of rigor, because you just can calculate and crunch through so many more physics and chemistry type equations that you can actually start to predict how a catalyst surface will behave rather than find it out by trial and error. And of course, it's artificial intelligence and machine learning to make sense of data from pattern recognition in ways that humans can't. So that's another area where we're building capability fast. And the deployment of that is a bit more near-term maybe than some of the electrochemistry, which is more of a long game. So which particular new technologies come out of that, I don't know. But I believe those capabilities will stand us in good stead.
One that I find really interesting is the artificial intelligence revolution. And since the rise of artificial intelligence, companies have rushed to demonstrate how deep learning can upend their business models. However, in an MIT and Boston Consulting Group study of 3,000 executives, they found that while 85% of them believed that AI would provide them with a competitive advantage, only 20% had extensively incorporated their findings into their product offerings. So what is Shell doing to incorporate AI, and how are methodologies or criteria being built in place to ensure that value is being generated from these projects?
Yeah. Well, in product offerings, that's a kind of more narrow definition of how you apply it, because of course you can apply artificial intelligence and machine learning in many ways, right, including in your own processes and decision making. But it's relevant for your products as well. So I can imagine not every company is there. We have a history of using compute to do our business, but now we've got a whole new era of being able to apply it. So we're building up our in-house capability fast. We're currently at a point of having about 200 really leading deep specialists in data analytics, artificial intelligence, machine learning. Partly that's people that were already in our company that were really cutting edge in statistics, and now using new tools, because essentially artificial intelligence is statistics on steroids. So we have a background and a basis that we can use, and partly by attracting new talent to the company. So about 200 really deep specialists that develop cutting-edge applications that are ahead of the industry. Then there's more than 2,000 people right now in Shell that can apply data analytics. We kind of call them citizen data scientists. So where maybe they are not deeply specialized and do this all day, but they know enough about the tools They can do basic coding in Python and use Alteryx and all other kind of platforms and deploy it on a daily basis because they're a process engineer or they're a marketing manager or they do things with data. Yeah. The third thing that we do to build capabilities is build relationships with other companies and suppliers and academia. So we've got deep relationships with some of the big three, and smaller relationships with others. Big three being Google, Amazon, and Microsoft. And then lots of smaller companies, emerging companies, C3 IoT. I mentioned Alteryx, Bonsai, and a number of other companies. And so between deep in-house expertise, broad deployment expertise, and partnerships, we think we can do as well, if not better than anybody else in the industry. We've got some super cool use cases up and running. For instance, here in the state of Texas, horizontal drilling in the pay zone. Drilling in the pay zone is complex. You have to constantly steer based on part information and largely rear view mirror information. And we deploy some of the same technologies that Waymo develops for autonomous driving for geosteering. And we can do that fully automated now. To the best of our knowledge, there's no other company that can do that yet. We use artificial intelligence to crawl through seismic data and find geological features. We use artificial intelligence in the downstream as well to kind of make sense of consumer data and do a whole swathe of other things. The big next step that many large companies are working is how do you then scale those use cases up? Often your data have not historically been built in systems that are easy to access and use all your data in the same way. Companies that have grown up digital, say Amazon, don't have that problem because they started without a legacy, right. And they started with a new system from scratch. If you're an established company, you have to segue from the data systems that you have in the platforms to a new world, and that's where a lot of the activity right now is.
So you mentioned carbon capture a while back. Do you see that, mastering that technology being able to have a big effect, or should we be looking more towards renewables and, other investments?
Yeah, so a repeat of what I said before, it's not the one or the other. If you look at any credible scenario that gets you to less than 2 degrees C, you don't have the luxury of choosing which pathways. You need every credible pathway to stay within the 2 degrees C. And that's electric vehicles as well as carbon capture and sequestration. We think that as a company we are well placed to help societies adopt carbon capture and sequestration because the core building blocks of the technology are very close to what we're typically good at. The process technology to capture CO2 from a stack is the type of process technology that we use in many other ways. So developing that technology for it to be affordable and safe and reliable, etc., is close to our core competence. Being able to assess the subsurface on where to stick the CO2 in such a way that it doesn't cause collateral damage and problems, and have monitoring and verification technologies that tell you that it safely stays down there is another area that's close to our area of competence. So we have demonstration projects that kind of show the world what the current state of technology is, what is possible. The biggest one that we've done is in Canada. It's called Quest. It's 1 million ton a year, so that in a sense it makes a small contribution. That's a couple of 100,000 cars. It's nowhere near enough what the world needs. The world needs gigatons to stay within the 2 degrees C. But it's a demonstration of what's currently possible. And then we have technology development programs in-house and jointly with others to bring down the cost of carbon capture and sequestration so that societies will actually adopt it at scale, plus prove that it can be done safely and reliably. For instance, a collaboration that we have in Europe, in Austria, with the University of Vienna and a number of other consortium players. There we test out a circulating solids technology to capture CO2 rather than liquid extraction technology. If you have circulating solids, you don't need to evaporate the liquid and then condense it back, and you lose a lot of energy in the process. So you can do it a lot less energy intensive and a lot lower cost. So it's a type of technology that can make the step to the next level of affordability so that societies take it up.
So we're going to have one more closing question. If everyone wants to start thinking about questions for Q&A, you can come line up. But in light of all the changes happening in the energy industry, what is your advice to the students in this room who are the next generation working in the industry, or anything you want to say to the audience? So.
Oh boy, that's the point of it. Can you please say something really thoughtful and wise? And so I'm not the Oracle of Delphi, and whatever I say comes with disclaimers in that sense. I think if you're interested to come and join the energy industry, it is a space where you can really have an impact. The world needs to make a lot of progress around energy. So you can actually, do something that is very material to societies that makes a difference. In order to be impactful, I think you need to have a broad understanding of all the aspects of the energy system, and you have to have one area where you go deep. So, popular kind of literature calls that the T model of personal development. In order to be able to have impact, you have to see the broader impact of what you do by understanding, the politics, the societal aspects, the economics, the technology in the broader sense, and the entire value chain. But you can't stop there, because then you're just a jack of all trades and there's nothing where you can specifically make a difference. So somewhere along that spectrum, you have to pick something where you say, at least the front half of my career, I'm really going to make a difference in that part of it, but I understand how it hangs together. So when you study energy, I would recommend that you have both elements. You pick something and you go really deep, but you also understand the end-to-end.
Well, thank you very much, and we'll open it up for Q&A.
May I ask a question? That's your position of highest level. You have to face real reform. And you also have to set it. How do you actually manage at your level? Let's just say, for example, hydrogen fuel cells versus batteries or something.
Yeah, it's a mystery really that I'm still there. I have no idea how I exactly do it. I mean, it's really important. What I said, the company culture is to play the long game. The company culture is to think about what ultimately makes sense in the long run through political, cycles, because pursuing something just because it's popular in any particular country right now isn't a sustainable way to go about it. The investment cycles that we have in the energy industry are decades. When you decide to go for something, your investment in, whether it's a chemical plant or a deep water platform or whatever, it needs to operate for 30 or 40 years for it to make sense. And therefore you always have to think about what makes sense in the long run. If you can't advance with something right now that makes sense in the long run, then you treat it as a future option. And a future option means you do some work on it, but you don't overexpose the amount of capital. If there's reasonable support for it and it makes sense and you can see it growing, then you treat it as a growth business. So you develop and you make sure it already has the size that it has returns so it can grow on itself. And then some things the world will still need for a while, but in the long run the world won't need it, so then you're not going to spend too much money on that renewing it. You just do enough to maintain its profitability for as long as it's needed. So there's a technology life cycle where some things are early in the funnel, where we do lots of small bets. And there's some things that are, fully mature, where you do very little, but just enough to be competitive. And then there's a sweet spot in the middle where you go big, and you invest fast to be ahead of everybody else. And managing a technology portfolio is a bit like managing, I'm not sure you're going to like this, but it's a bit like an insurance portfolio. If you would say, as an insurer, let me pick the 5 most profitable customers and shed everybody else, well, that's not going to be very successful, because sooner or later one of those 5 is going to have their house on fire and your entire business will collapse. So you have to maintain a broad portfolio of activities as an insurer, but also when you run a research portfolio of $1 billion a year. There has to be enough diversification in there that lots of things can fail, and you still have enough things get across the goal line ultimately and build your future successful business.
So, of course, have a weakening technology.
A weakening technology.
Technology that is unfortunately very process to recognize that weakness and rebuild it.
Well, we can't make whole societies make choices simply because of the progress that we make with the technology. We want to make sure that those technologies that societies ultimately support are ready when that happens, and we are ahead of our competitors in the ability to, pick up on the opportunity. And we have a fair amount of that type of activity. We spoke about carbon capture and sequestration. When we do the scenarios for the long run, we believe that ultimately it's a matter of time before suddenly societies realize that they will need this. Right now, it's not very popular with most societal players. So we can do a certain amount of advancement of that technology, but because the scale-up is not imminent, we can't throw the whole $1 billion a year at this. We can do enough to stay ahead of everybody else and to keep making progress so that by the time suddenly people realize we need this, we are ready to deploy in a competitive way. We are investing in hydrogen mobility in Germany. So we pick one whole market where we go big that might be a demonstration market for everybody else. That market right now is not Texas. In Texas we can do other things that consumers want. Right now it's not hydrogen mobility. In Germany they might want it. Is that profitable on day one? No, it isn't. But you have to break through a chicken and egg cycle where you have to put infrastructure in place where people can actually drive up with their hydrogen fuel cell car and fill it up in order to sell more hydrogen fuel cell cars. But the other way around is true as well. If you just build the filling stations and there's no cars on the road, then that's not very useful. So you have to do it together. There's a partnership approach. So we do this in a consortium. 6 big players, 2 large automotives, 2 industrial gas companies, 2 energy retailers. We are one of the 2 energy retailers. We team up between the 6 of us. We kind of share the burden, and we build 400 hydrogen fuel retail stations across the company over a 5-year period. And then, of course, what's in it for these 2 automotive companies? They might sell more hydrogen fuel cell cars, and we might have an edge in how you do that competitively. So those are coping strategies with,
Yeah, I really liked how you said that part of your business is turning molecules into other molecules. So of course chemistry has been doing that for centuries now, but actually it's been going on for billions of years in nature. So what do you think is the role of synthetic biology and bioengineering in this sector going forward? Is it going to be more prominent or be about the same, or will chemistry, or specifically man-made technologies, will they come to dominate nature after all in the end?
Oh, wow. I do believe that synthetic biology will certainly be very important as a future production process of things that people in society want and need. How big the role of it is going to be in energy is harder to answer. So I think definitely in pharmaceuticals and in other industries, synthetic biology is going to be core and central to the success of those future companies. The hard thing in energy is we don't know exactly how much biomass or any bio feedstock is going to be a future source of energy. I think the world kind of 10 to 15 years ago forecasted a bigger role for biofeedstock than we currently see evolving. Because in the last 10, 15 years, we've seen especially solar PV make a lot more technology progress than was expected 15 years ago. Because of that, the role of bio-based energy is probably going to be a little bit smaller. We can still see molecular energy carriers that we will need, for instance, for aviation, where biofeedstock might be very important. And then you can see synthetic biology being part of the answer. I think there's another component to it that is growing where it might be more relevant, and that's not so much in the provision of the energy, but in offsetting unavoidable CO2 emissions. So we can see in all these scenarios also of the IPCC that the role of nature-based solutions is starting to become ever more important in getting to net carbon neutral. So can we see crop yields be much higher in the future as an offset for carbon? Can we see different forms of agriculture where you leave more of the carbon in the ground and less goes into the atmosphere, that help us balance supply and demand of CO2 into the atmosphere. Exactly how that plays out, I can't do a prediction there.
Continuing the conversation about those different resources. So we talk about energy, we usually think first about the energy resources, either fossil renewables. But now with the change in the infrastructure and the solution that we think about for the future, it often comes to the question about the availability of other resources that's required to build that infrastructure to really support those solutions, particularly in a larger scale and in a short time frame that we talk about. And I'm talking about the rare earth metals, the copper, you name it. Essentially, there is a long list we've been discussing for their solutions worldwide. My question is, with the Shell, with that kind of portfolio of options you're considering, how much of your thought process goes to looking at the potential constraints in those resources? And with that, how much do you work or plan to work with different other resource providers to support what you see as a possible winner solution?
Okay. Well, definitely factoring it into what are credible pathways for future energy systems, yes. That doesn't always mean that we choose to then make it our business to go into that type of resource. So, cobalt availability for current battery technology around lithium ion, like everybody else, we can see that the stability of the only major source for cobalt in the world is not very good and has lots of complexities with it. That doesn't mean that we then choose to go into the cobalt business. So we would then say, okay, what might the impact of that be on future technology? And we actively, work with others to see what the next generation of battery technology might be that doesn't require cobalt. And there's other examples like that. So yes, we factor it in, and then we make a conscious choice. What do we then do with that? We either kind of shy away from that technology, or look for another option. Solutions might come about. Yeah, you shouldn't always think that the constraints as you can see them in front of you now are going to always be there. I think 10 years ago, lots of people wrote that lithium-ion batteries as a technology was going nowhere because there wasn't enough lithium in the world. That was, popular to write for some time. Currently, that's not really a big perceived constraint anymore. There's enough large kind of conventional, sources already, and people can kind of calculate their way to getting enough lithium from the oceans that, ultimately there's no supply risk at all, really. So don't accept the constraints as they present themselves in the here and now as the only possible path forward.
I really appreciate Shell's commitment to sustainability in a field where that's not generally the primary goal. But at the same time, being a competitive energy company, you generally as a company, you have to go with the option that in the moment provides the most value for your shareholders. And Shell, in this case, some people might question its commitment to sustainability when it takes an active role against regulations in the EPA. For instance, last year, Shell was a member of one of the oil groups that was lobbying against a bill that would, against the bill that maintained frequent methane checks. So I was wondering if your status as a competitive energy company conflicts with your status as or commitment to sustainability as well.
Sure, good question. On the specific content of this particular point, so we are strongly in favor as a company for much more methane leakage checks. And we invest in technology to do it. Satellite-borne technologies, drones, all kinds of technologies. And we have committed ourselves as a business to get our global leakage rate of natural gas, of methane, down to 0.2% by 2025, which, compared to where the industry typically is quite a hairy goal, but we realize it's important. Now, sometimes you find yourself being member of a club where you agree with many of the things that that club says and not everything. And now you have to make a decision whether you cease being a member of that club or you kind of decide to have your own opinion publicly on that particular point, but you still stay part of that. So we observed this particular debate, and what we do is we are transparent that our own position is we should have a lot more measurement of methane, and it's very important that the industry at large makes sure that they really control leakage of methane. And then we have to assess, whether this particular group is still something that we should be part of. We have had occasions in the past where we decided to leave, an industry representative body, where we felt that their opinion in society was different from ours on too many things. And then we say, okay, then we can't be part of this anymore. I also believe, and the company believes, that at a grander scale, what is good for your shareholders is what is good for your shareholders over the long run, which isn't the same as what is the economic optimum today. We are fortunate that because of the nature of our company, we mostly have large institutional investors. Because being a mature and super large company, we're more a returns stock, a dividend-based stock, than a growth stock. And the type of investors that you then have tend to be large institutional investors, pension funds, etc. And they look for sustainable long-term yields as well. So we can typically have a dialogue with our investors that what we should be doing is what is good over the long run, rather than what's the optimum this year. And we don't typically find ourselves in conversations where we get pressure to do something that's more profitable now, but clearly the wrong thing to do if you think a decade out. So I don't see that dilemma play out that much. What is much more difficult is back to the energy transition. How do you balance continuing to provide the energy that people need today based on the technologies that are available and building something for the future? Because just cutting off oil production today not only kills off the company because you don't have the income to fuel investment in your new business, it also does nothing good for the energy system at large. We are less than 2% of global oil production. If we decide that we're not going to produce any oil anymore, that doesn't move oil consumption in the world one tiny little bit. So that's unhelpful. So that's the more difficult dynamic, but it's not so much the kind of the near term versus the long term. That we can jointly with our shareholders kind of work our way through.
Hi, you touched on carbon capture and sequestration. If instead somebody has a solution where you could environmentally do CO2 capture and utilization, to create hydrocarbons to combat global warming, who besides your Game Changer program could you reach out to?
This guy sitting in the corner here, he's a general manager in my organization, and he runs our long-range research program. And actually one of the core programs that we have is how in the long run could we utilize CO2 and other chemical building blocks to make dense energy carriers or building blocks for materials use. A big challenge is the volumetric mismatch. If you wouldn't make dense energy carriers, i.e. fuels, but materials, then the world uses a lot less materials than it emits tonnage of CO2. So you could get some level of carbon capture and utilization, but even if you would supply all the construction material in the world based on that, you would still have a whole bunch of CO2 that you don't know what to do with. So energy carriers is then the only one that is volumetrically big enough that could make a real difference. But we're super interested in any technology development in that space.
We're currently working with Delft University and also Leibniz Institute. Have a solution.
And that's another thing we have in common because we work with Delft University as well.
Okay.
Thank you.
And with that, we'd like to conclude the Fireside Chat. Yuri, thank you so much for taking time out of your day to speak with us, as well as for coming and visiting our campus and sharing your insights. And we're definitely looking forward to seeing the direction that you take the company moving forward within the energy transition. So thank you.
Thank you very much. I really enjoyed it.